Hello there. Welcome to this video. We are starting a new standard, so we're not doing rational functions anymore. We're actually kind of switching gears. We're going to talk about inverse functions. We're going to start with the basics of inverse functions for a couple weeks. Then we're only spending 1 week on another standard, finding inverses. It's pretty quick. It's just one little thing. We're only spending 1 week on it, and because we need extra time on some of the more difficult stuff. This video is for the first week of inverse basics. I'm going to introduce what an inverse function is. I'm going to show you the definition and then how the definition applies, because then that's going to be easier to see. So anyways, the definition of an inverse function. So let's assume that I have a function. We all know that this is true. Right? We were taught that in SM1. That y and f of x are synonyms, they're interchangeable. Most of the time we use y equals if we're looking at a graph, and we use f of x equals if we're looking at the function, like the algebra side of it. The inverse of this function, by definition, is this. So if I have a function, if I have an equation, and I plug in an x, I get out a y. The inverse function is a completely different one, right? Completely different in almost every case except for one. Yeah, every case except for one. But the inverse function is a different function. That's why we use a g instead of an f. If I plug in the y of the original, I get out the x of the original. So here, this is my input. This is my input and my output. With the inverse function, my output actually becomes my input. Right? The output is what we put into the function. And the input becomes the output. It's what we get out. Okay? The notation we're going to use. And you have to use this. Okay, no choice. If I have a function, this is how I write the inverse of that function. So f to the negative 1 of x. That does not mean an exponent. It does not mean to the negative 1 power. Okay, if you go research this, you're going to find a bunch of memes where uneducated people say, oh, what's this mean? Oh, that's to the negative 1 power, which is this. Well then, what does this mean? Oh, well, it should mean this. But it doesn't, and then they try to make fun of teachers and stuff. It's because they're uneducated and they don't know what they're talking about. Okay, there's a reason, and you're going to be educated, and so you can tell these people that they're wrong. Okay, the reason why this isn't an exponent is because when we use this notation and it touches the function, see how this is f? That's the function, it means inverse. If it's connected to the variable, that's when it means exponent. So here's our function, the negative 1 power. It's not a power, it means inverse when it's connected to the function. When it's connected to the variable, it means exponent. So here, let's see, at the beginning of quarter 3, we're going to talk about, and you've already talked about this a little bit in SM2. We're going to talk about the sine of x, that function. We're actually going to graph it and stuff. Last year you talked about the definition, right? How it looks on a triangle. We're actually going to graph this and stuff this year. When I write it like this, notice the negative 1 is not with the variable. So it's not to the negative 1 power. This is the sine of x. It's the function. Sine is the function name. So because the negative 1 is with the function, it means inverse. Right? So you need to be aware of that. You need to be very careful. Okay, this does not equal this. Because this is not a power, it means inverse. I know I'm beating a dead horse right now, but this is extremely important moving here on out. All right, so I'm going to beat the dead horse a little bit. Okay. So let's talk about some inverses that you already know about. Right? What's the, and I have some questions here, so just follow along. What's the inverse of addition or of add? Subtraction. So the inverse of addition is subtraction. What's the inverse of multiply? Sorry, that's also, well, you know what I mean, multiply. It's division. What's the inverse of an exponent? You learned this last year. So like a squared, it's the square root of a. Right, the inverse operation of an exponent is a radical, is a root. Okay. So notice, and you all know this because I've talked to you about this before, but inverse operations, they undo each other. Right, they don't cancel each other out, they undo each other. Right, so plus 3 minus 3, you get 0. It undoes itself. You get the, man, I just forgot the word. Sorry. It'll come back to me. I'll tell you. It'll come back to me. Okay, so inverse function. Based on this, if inverse operations undo each other, what do you think happens with inverse functions? Inverse functions undo each other. But not just one single operation. They undo everything. That's why they're inverse functions. So if you do something, we're going to talk about this next week, but if you do something called a function composition, if you plug one function into the other one, and everything is undone, and you're left with just an x, then you have inverse functions. Because everything undid itself. Because they're inverses. They're opposites. So looking at the domain and range, we already kind of talked about this, where I showed you that the input value becomes the output value, and the output value becomes the input value. Well, we know those by different names, right? We know those by x and y's, or domain and range. So I have this graphic for you. I'm going to show you this example on the board, the x, y. So let's see, -5, -3, -2. -3, 2, 0, 8. Sorry, I'm trying to hold in a sneeze. 3, 14, and then 5, 18. Okay, and then the other one I have is -2, -5, 2, -3, 8, 0, 14, 3, 18, 5. These are functions. They are inverse functions. Notice here. My x was -5, my y is -2. My inverse, my x is -2, my y is -5. The input, output, input, output. The input variable to the inverse function switched to the output. And the output variable switched to the input. Essentially what happened is the x and y values switched. Okay? The domain switched with the range. Okay, so in the original function, you have a domain. The domain of the original is the range of the inverse. And the range of the original is the domain of the inverse. The x and y's, they switch. Domain and range switch. Okay, and that's one of the biggest characteristics of an inverse function. The domain and range, the x and y's, they switch. So let's do this practice here. So let's see here. I have x, f of x. Let's see, this is 3, 2, negative 4, 5, 0. And then over here I have x, f inverse of x. This is negative 4, negative 4, 7, 5, 0, 3, negative 4, 2, 5, 0, and blank. Okay, so let's look here. I want to fill in my x and y values. But this is my inverse. Look, it's to the negative 1 power. So these are inverse. That means this is the output. This is the output of my original function. Well, here's the output. It's the y value. Right here, I'll put y here in case. The y value. Here's your x value. That means that my output for my inverse is actually the input or the x values of the original. Right? Domain and range switch. X and y switch. So if I switch my x and y's, my x is now negative 4, and my y should be, let me use a different color so you know which ones were filled in afterwards. 3. Okay. Once again, to go from my original function to the inverse, I switch my domain and range, my input, output, my x's and y's. So my x becomes my y, and the y becomes the x. Okay, here, the y value becomes the x, and the x value becomes the y. They switch. The y value becomes the x value becomes the y. And then here, the x value becomes the y value becomes the x. They switch. Okay. Let's do the second one. Sorry, I don't want to erase the whole thing and have to rewrite it, so I'm doing little bits at a time. Okay, so let's see here. We have 5, 9, 4, 5, 6, negative 3, negative 8, 2, 2, 6. This is 5, 5, 6, negative 8, nothing. So once again, my x value became my y value on my inverse. So my y value becomes my x value on my inverse. So here, this should be a 4. This one's negative 3, right? X and y switch. 2, x and y switch. 6, 2. Okay. All right. Let's move on. Now, we can only find the inverse functions of a one-to-one function. Okay, you can't find inverse functions for other functions. Now, you're going to think when I show you go through this stuff, you might think, well, but you're showing me inverses of all the functions that I know, which is true. You have to do a little bit of finagling. You have to restrict the domain, which we'll talk about. Don't worry. Okay. But by definition, you can't find an inverse of a function unless it's a one-to-one function, and that's what we're going to talk about. So in SM1, you talk about what a function is. So let me draw. I'm gonna use these right here, these pictures. So let's see. I have my x values, the domain. So we have 5, 7, negative 3, 2, And here I have my range, my y values, 1, 0, 4. Okay, and then we have some lines here, and here. Okay. So the definition of a function, just to remind you, is every x value has only one y value that corresponds with it. So every x value has one and only one y value that it corresponds to. For example, if I did, let me erase these lines. I did this, put a 4 there, and I put a 3 there, and I did this. Okay, every x value does not have only one y value. See, x of negative 3 has two y values. It comes out as 3 and 4. Okay, this function right here, plus or minus the square root of x, is not a function. So I shouldn't have said function. Because if I plug in 4 for x, I get positive 2 and negative 2. So I have one x value, but I get two different y values for that one x value, so not a function. Okay, so a function is where every x value has only one y value. Now the y value can have more than one, right? Like here, the original one we had. Okay, that original one we had, that's still a function. The y value had more than one x value that coincided with it. And that's okay, right? That's how we get our parabolas. Right, x squared. Okay, you have here like positive 2. You have an x value over here and an x value over here. That's okay for it to be a function. Now 1 to 1. Okay, this is the new thing I'm introducing. You already knew this. This was just a review. 1 to 1 function is every x value has only one y value. I did that in reverse order because I'm looking away. Every x value has one y value, and every y value has only one x value. 1 to 1. So this right here is a function, but it's not 1 to 1 because that y value has two corresponding x values. But if we do this, every single x value has only one corresponding y, and every y value has only one corresponding x value. This is 1 to 1, hence the name. One x value to one y value, one y value to one x value. 1 to 1. Now there's a way to check this graphically. Okay, in SM1, they taught you something called the vertical line test to figure out if something's a function. All right, so let me put my parabola back here. We'll do this. Okay, the vertical line test says if you pick any vertical line anywhere on the graph, and that vertical line only crosses the graph one time, it's a function. So for example, here's a bunch of different vertical lines, but every vertical line, let me do this a little better. Boom, 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 boom. Every vertical line only crosses the graph once. This is a function. Okay, now if I did this, and do a vertical line test, oh, it crossed twice. Okay, that means that it's not a function. Okay, and it comes from that this x value right here, right, this x value right here has two y values. Okay? Remember, a function, every x value has only one y value. Every y value can have two x values, but the x values, the inputs, can only have one output. That's a function. Now, one-to-one function. We use the vertical line test to tell if it's a function. If it is a function, we use the horizontal line test to see if it's a one-to-one function. So let me bring back my parabola here. Here's my parabola. Okay, we did our vertical line test. So we know the parabola is a function. Okay, we know that, what is this, x squared minus 5, maybe, is a function. Now to tell if it's a one-to-one function, we use horizontal line test. So I'm going to draw a horizontal line. It crossed twice. It is not a one-to-one function. All right, and that's because our single y value has two different x values. And remember, one-to-one means that every y value only has one x, and every x only has one y. But here we just showed that this y value right here has an x value here. Oops, got ahead of myself, got into some trig. And has an x value here. So both of these x values on the function would give us this y value, which means it's not one-to-one. So horizontal line test. So let's look at our graphs. Let's see, I have one that looks like this, right on your paper. Vertical or horizontal line test, crosses twice, not a one-to-one function. Right, so not 1, 2, 1. Sorry, that green is kind of losing its ink, so I'm going to throw it away. The next one kind of looks like that. Horizontal line test. Nope, there's nowhere do I cross the graph twice, so it is one-to-one. And then we have here. Something like that. Horizontal line test. It crosses it actually 3 times. So once again, it is not one-to-one because it crossed more than once. And that's it to determining if something is a function graphically. Right, so that question on the test is almost a gimme. Right, just use the horizontal line test. If it crosses more than once, not one-to-one. If it crosses only once, it is one-to-one. Okay, last page. So like I was saying before, you might think, well, some functions will never have an inverse because it can't be one-to-one. Right, so our parabola here, it's not one-to-one, so it can't have an inverse. What we end up doing is we restrict the domain, just like you did with piecewise functions last year. I'm going to restrict the domain. I'm only going to use x values that are greater than or equal to 0. So that's this side of the graph. Well, now if you do the horizontal line test, it only crosses once. So now you can have an inverse of that function. Okay, so that's what we end up doing to bypass that definition, is we restrict the domain enough to where we do have a one-to-one function. Okay. Now, last little bit is how to determine if a function is an inverse of another one graphically. So how do I determine if two graphs are inverses? Well, let's look at our parabola again. Okay, now remember, an inverse function, the x and y values switch, right? They flip, they switch. So, we're going to take a reflection over the line y equals x. So here's our line y equals x. It's actually a 45-degree angle line. The reason why we use the line y equals x is because we switch x and y. We treat them as equals because, right, when we do something like this, 3x plus 1 equals y, and I plug in 2 for x, I'm saying that x is equal to 2. Right? I'm saying that x and 2 are the same, they're equal, so I can interchange them. Same thing with the inverse. We're saying we're treating them as equal, so we're flipping them. So the reflection of the graph is across the line y equals x because we're treating them as equal. So if I reflect this graph, okay, I'm going to take everything and reflect it over. And what I end up getting is that. Okay, so every single point here, this point reflected over to this point. This point reflected to this point. This point reflected to this point. All it is we're taking every single point and flipping it this way. Okay? Now, this point right here reflected up here, and this one reflected up here, right? So these were on the bottom side. They reflected to the top side of that y equals x. So let's look at this real quick. This part right here. I told you that those were inverse functions, right? Let's graph them and see if it's true. Here's my coordinate plane. So I have negative 5, 1, 2, 3, 4, 5, negative 2, 1, 2, right there. And I have negative 3, 2, 1, 2. So negative 3, positive 2, right there. And then I have 8, 1, 2, 3, 4, 5, 6, 7, 8, 0. And then I have 3, 14. Or sorry, not 8, 0. 0, 8. 1, 2, 4, 5, 6, 7, 8. 0, 8 is right there. And then I have 3, 14. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 3, 14. Sorry, I know I'm in your way. Give me a second. 8, 9, 10, 11, 12, 13, 14. 3 is about right there. Okay, and then 5, 18. 5, 18 is about right there. Okay, let me draw that line. Get a straight edge here. Make it look nice. There's my straight edge. Get nice and pretty. Not perfect, but it's pretty close. Okay. And that line's going to go on forever, right? There's my points. I'm going to make them nice and big so you can see them. Should there be 5 of them? Oh, there's my other one. There's my other one. Okay, so nice big points so you can see them. Now my other one, I'm going to graph blue. So negative 2, 5. So negative 2, negative 2, negative 5. So there is 1, 2, 3, 4, 5. Negative 2, negative 5, which is right there. And then we have positive 2, negative 3. So here's positive 2, there's negative 3, so about right there. And then we have 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 0. So right there. Nice big point, nice big point, nice big point. Here you can see, yes. Okay, 14, 3. So it's 8, 9, 10, 11, 12, 13, 14, 3, which is about right there. And then, oh, sorry, that last one, that's a typo. That last one, it should be 18, 5, or 18 over 5. All right, so the x should be 18, and the 5 should be the y. That's my fault. 15, 16, 17, 18, and 5. 1, 2, 3, 4, 5. About right there. Okay. Once again, let me get my straight edge, make it nice and pretty. Okay, they're not exact. That's okay. Almost though. Woo! There we go. There's that line. Okay, give me the benefit on the doubt there, or benefit of the doubt there. So there's my graph. Those are my two graphs. Now let me draw the line y equals x. Actually, here, I'll do right there, right there. Okay, not perfect, but close enough. The red is my line, y equals x. We're going to see if these points are actually inverses of each other. Well, notice, this point reflected straight across the y equals x to that point. This point reflected straight across. This point reflected straight across. This one reflected straight across. This one reflected straight across. Okay, fun fact for geometry. If you measured these angles, those would be all right angles. Isn't that awesome? That's so cool how that works. Because it's the reflection just straight across. Right? And so because we see the relationship, because these points were reflected directly across the line y equals x, we do know for a fact, we knew for a fact before anyways, but graphically we know for a fact that these two sets of points, they are inverses of each other, in fact. Okay. And that's it for the lesson. So not too bad. Next lesson is actually going to be, I think, a little bit shorter, just so you know. I tried to get the long stuff out of the way first. Don't quote me on that, though. All right, once again, if you need extra help, if you don't understand the stuff and you need me to explain it to you in person, come in after school, come in before school. I'm always available to help you, but you got to let me know what you need. Right? I can't read minds, so come talk to me. Okay, that's it.